Okay, I need to apologize being a little childish with the MSU thing. I just couldn't help it, but I'll let it go. Here's 5 problems that are radicals. I'd like you to do them right now. They're a little bit harder. And then turn me back on when you got it. Well, hello, hello, hello. So the first one, you multiply by 3 plus square root of 6. So you distribute, that'd be 3 square root of 3 plus square root of 18. Then 3 times 3 is 9, minus 3 square root of 6 plus 3 square root of 6 is 0. So that's gone. That's why we're doing this. Then minus square root of 6 plus square root of 6, when you multiply, it's minus square root of 36. So this is 3 square root of 2, so we have 3 square root of 3 plus 3 square root of 2, because 18 is 9 and 2. Done that a lot. Square root of 36 is 6. 9 minus 6 is 3. So this reduces because they all have 3. So it'd be square root of 3 plus square root of 2. Yowzer! I gotta sneeze. Okay, so, they're both cube roots, so I can multiply them. Don't have to have the same radicand when you're multiplying it. But when you're adding, you gotta have the same radicand. So it'd be 4 times 6 is 24. X to the 16, because when you multiply two things same base, you add. Y to the 33, Z to the 8 doesn't have anything to go with it. Zippy zoo. So I'm going to break this both into perfect cubes. Perfect cubes. So 24 would be 8 and 3. 8 is 3 2's. X is 16. I need a power divisible by 3, so it'd be 15 in X. Y to the 33, hey, that works out perfect. Z, I break up Z to the 6 and Z squared. Let's bring it up there. That's a little bit better. See? So this would be 2x to the 5th, y to the 11, and Z squared, and the cube root of x, Z squared. Okay, this one. Oh, it's easy. No plus or minuses, so it's 8 square root of 50. So square root of 50 is 25 and 2. Still got that 8 there, so it's 8 times 5 times square root of 2. So it's 40 square root of 2. Now this one. You could just multiply top and bottom by square root of 20. That is fine. But I like to simplify this. So this would be 2 over square root of 4. Square root of 5, because 20 is 4 times 5. Square root of 4 is 2, so it cancels this, so we now have this problem. 1 over square root of 5. So you multiply top and bottom by square root of 5. So it's square root of 5 over 5. Because square root of 5, square root of 5, square root of 25, which is 5. This one, oh, I see pluses or minuses, so let's furl it. Square root of 2, square root of 2 is 3, square root of 4. This times this is minus 3, square root of 6. This and this is plus square root of 12. And this is minus square root of 18. Yes. Square root of 4 is 2, so that'd be 6 minus 3 square root of 6. 12 is 4 and 3, square root of 4 is 2. And as we've said 84,000 times, 18 is 9 and 2, so it's 3 square root of 2. Yay. This one. Now, I need 3 of the same thing. You could do this 2 ways. You can multiply by cube root of 25 and cube root of 25. That's a mess, but you can do it. Or you could say there's 2 5s in 25. So I'm going to break this up. Well, not break it up, but multiply by the cube root of 5 is what I was trying to say. So I'd have 5 cube root of 5 over cube root of 125. So it'd be 5. Oh, let's see. Cube root of 125 is 5. And 5 goes into 5, so my final answer is cube root of 5. So cube root of 125 is 5. 5 and 5 cancel. This one. Now I need to get rid of the radical. It's the 6th root of the 4th root of 4. Turn me off and do it. Okay, so you need 4 of the same thing. So you could multiply by 4th root of 4, 4th root of 4, 4th root of 4. That'd be 4 of them. Or you could say I have 2 2's. So I need 2 more 2's. So this would be the 6th 4th root of 4 over the 4th root of 16. The 4th root of 16 is 2. 2 goes into 6 3 times. So it'd be 3 4th root of 4. Yay! Okay, let's do some imaginary. So I'm going to flip it over. Yeah, okay, so let's see what we have here. What do we have? Well, okay. Well, let's do a identification. Classic country. Makes you cry and makes you ask why, but it gives you a little heart. Okay, back to math. Okay, so now, if it said simplify over the real numbers, couldn't do. You just say can't do it. Because there's no real number that gives you a square root of negative. There's no perfect square that's a negative. But if it says over the complex numbers, we can do it. This is 3i. This is 2i. So it'd be 6i squared. We know I squared is negative 1, so that's negative 6. So, oops, sorry about that. Earthquake, So, do those problems for me. Turn me off. And then I'm going to float right through them. Okay, good. So this is 3i plus 2i, which is 5i. This is, break it up, 25, square root of negative 1, square root of 2, so it's 5i square root of 2. I is I cubed, and we just learned that I cubed is negative I. This is 32i to the 5th. We learned we break up the I to the 4th I. I to the 4th is 1. I is I. So this, 7i plus 6i, if you get this wrong, I am allowed to eat your lunch. 2 minus 6i, then distribute the minus 4, so it's minus 8 plus 12i. Don't forget the negative goes into both parts. That's where most people mess up. So this would be 2 minus 8 is minus 6. Minus 6i plus 12i is plus 6i. So distribute the 6i, it's 12i minus 24i squared. But wait a minute, I squared is what? Negative 1, yes. Negative and negative is plus, so it's 24 plus 12i. So, okay, turn me off and do those 6, and then we're done for the day. Okay, so we got a square here. So it's got a plus, so we write it twice and foil it. Trying to speed up because I'm about to run out of my, I think I'm going to go way over 10 minutes here. So 9, 3i is 6i plus I squared. Wait a minute. I have a thought. What did I don't know. Oh, I guess I don't. So I squared is negative 1, so that would be 8 plus 6i. This one, we need to FOIL it. So it's 4 times 1 is 4, minus 2i, minus 20i is minus 22i. And minus 2i minus 5i would be plus 10i squared. That's a minus 1, so 4 minus 10 is negative 6 minus 22i. And wait a minute, this should be easy too, I hope. So 6i over negative 5. Now this one, you got to multiply by the, you remember what it's called? What is it called? That's right, 4 plus 2i. 4 plus 2i. So 8 plus 4i over, FOILed out, 4 and 4 is 16, minus 8i plus 8i is 0, minus 2i plus 2i multiplies minus 4i squared. But r squared is negative 1, so 16 plus 4 is 20. So it will reduce everything by 4 because you can. It has to go in all three terms though. So it'd be 2 plus I over 5. Okay, now we got some challenging ones. I'm getting nervous. So, light just got brighter. I don't know why. So multiply by the conjugate. So it'd be 12i minus 4i squared over 36 minus 4i squared. Now be careful. You cannot cancel these two terms because of that minus. If it was 12i plus 4i squared and 36 times 4i, then you could. But the minus and the plus mess it up. Let's make sure I didn't make a dumb mistake with that. I feel kind of like I made a dumb mistake. 36, I guess I got it. So this simplifies. I squared is -1, so that would be minus. And times the negative is plus, so it's 4 plus 12i over minus minus plus, that would be 40. So 4 goes in all three, so it's 1 plus 3i over 10. See? 1 plus 3i over 10. Then this one, the conjugate's 4 plus 3i. 4 plus 3i. So that would be 16. 12i. 12i is 24i. Plus 9i squared. So 4, 4, 16. 12i, 12i. 3i and 3i is 9i squared. But I squared's -1. So it's 16 minus 9 is 7 plus 24i over 16 minus 12i plus 12i is 0, minus 3i plus 3i is minus 9i squared, which would be 25 because minus and minus is plus. I don't know why. I feel like I messed up that top one. 16, 12i is 24i, and then 3i, 3. Yeah, I feel like I messed it up for some reason, but it looks right. Okay, whew. One last problem. Where do I put it? I don't have much room. Okay, let's do it here. I to the 48, what would that be? What's I cubed? Wow, 48 and 3. I don't know where that comes from. And I to the 449. Simplify that real quick. I'm about to run out of time. Well, I'm about to run out of time. Somebody did anyways. I got 15 minutes for these. So this is divisible by 4. So this is the same as I to the 4th to the 12th. I to the 4th is 1. To the 12th is 1. I cubed, we already know, is I negative I. I to the 449, we break up I 444 and, wait a minute, I 448. I'm sorry. And I. So this is 1, so the answer is just 1i. Boink. So you should never have a power bigger than 1 on your I. So I don't really have much more to say. Just nothing else in my mind right now. So I better get going. Of course, when Michigan loses to Wisconsin next week, I'm sure you're going to express it to me. But anyways, stay happy. Bye.